This talk is mainly for people, well, hopefully maybe you saw the working effectively with legacy Android code earlier today. This talk is going to be very complementary to that. I'm not going to go into code examples of how you actually fix tech debt, but this is about tackling tech debt as a larger entity, as a force in your code base that needs to be reckoned with. Ideally, if you're someone who knows that your tech debt is a problem, but maybe needs some help convincing your manager to let you work on it, or maybe need some help like just organizing it, categorizing it, this is going to help you out. So we're going to go over what is tech debt, what is legacy code, how it accumulates on Android in particular, various tools to identify tech debt and prioritize it so you can work on it in the right order, and a process for your team to plan and organize and actually get going working on this stuff. So a little bit about me. I'm Kate Kelly. I work at Etsy. The views are my own in this presentation, et cetera, et cetera. And before I worked at Etsy, I worked on a bunch of greenfield code. I was working in consulting. Different clients wanted different stuff. I was writing new code all the time. It was great. It was shiny. But then I would also work with code that had come from other contractors, and it was really scary. And this was introduced to me as legacy code. And it had all like the bad stereotypes you think of. The 3,000-line activity, total spaghetti. Like, no one wanted to touch this at all. So my introduction to legacy code was that legacy code is bad. But then I came to work for Etsy, and legacy code was still there, but it wasn't that bad, and I was very confused. Because isn't legacy code supposed to be this horrible thing that you run away from? But it can actually be kind of fun to work with because it can be a puzzle, it can be challenging, and we're going to look at it with some optimism. So first, let's look at what is tech debt. This was concept created by Ward Cunningham back in a while ago. He was working for this financial software company, and he had to explain to his manager, hey, we've shipped all this code, but we've gone into debt a little bit. Financial company, so words that the manager will understand. And as long as it's paid back promptly, this is fine. But over time, it'll gather interest. The debt is not repaid. And we're going to be in kind of deep trouble because we're spending all this time that's not right for the task at hand. So that's tech debt. What's legacy code? It's not quite this. It's not just all the code that was written before you came to your current company. Don't do this. This is bad. So, okay, it's code from before you were hired, sure. But let's keep going a little bit. Maybe it's code from before anyone on the team was hired. It's truly a legacy left from before. But maybe it's code that just kind of makes you afraid to touch it. Maybe even if someone on the team was there, it's still kind of not great. But really, it's code without tests. So thank you, Android, for being so untestable. So how does it accumulate? And this is going to be Android specific, really. I loved this talk. You all should go check out this talk. It's by Jesse Wilson. It was at droidCon New York City. It's called Writing Code That Lasts Forever. And in the closer to the talk, he says, our code base contains a history of every single thing we've ever done to do networking. And hopefully you can see this up there. We have Volley, we have Retrofit, we have Retrofit 2, JSON, Moshi, Apache, HTTP URL connection, everything. Async task. And you see these really good libraries in there. You're like, oh, well, that looks like a good code base. But the problem is that we have these really good libraries, but there's also all the old ones. So it's kind of like an archaeological dig. You go in and you're like, okay, Retrofit 2, Moshi, cool. And then you try to just do something else in a parallel section of the code, and you're like, custom callbacks and JSON, or maybe something even different. So we want to try to avoid this. So if you're coming into the code and you're a new person, how do you figure out the right way to do things? Do we have a sort of guiding principles of the code base? Do you just make a new layer with your new favorite libraries? That might not be great, because it might just add to that whole stack you had before. So we hear this a lot, that Android moves fast. Does it really move fast? Well, was your target SDK version behind on November 1st? Maybe. We've had all this new stuff recently, permissions, DOS, notification channels. The material design overhaul was back in 2014, but if you're still supporting devices on KitKat and lower, maybe this doesn't even register for you. And we have so many important changes like the cheese slice and the hamburger emoji, which is my favorite part of this Wikipedia article. Basically, don't switch just because it's cool. Like, all these new libraries are coming out, Room is out. Room is awesome, but do you really need to use it for your app's local storage if you have something that's already working? Well, if you can totally replace it with Room, great. But if not, then maybe you'll get into that multi-layered thing we saw earlier. It's a little bit spaghetti monster. So let's look at some tools to identify and prioritize tech debt. So we all have been in the situation. Google's now forcing us to update our Target SDK version so that we can actually publish our app updates to the store. And maybe you had some tech debt related to Target SDK version. Maybe you didn't have like a notification channel set up properly, and you had to like really quickly get it in for November 1st. So is there something we can learn from a mad scramble like this? Are managers aware that there might be these pieces of tech debt or older code that are in your app that need to be updated for the Target SDK, but it's just like, oh yeah, we'll just update it. But there's actual work that needs to be done there. So on the flip side of Google forcing us to update is that Google's forcing us to update. So you can actually use this as an opportunity to get ahead of the curve. Everyone's going to need to do this. You're going to have to go back and refactor old stuff to work with the new thing. No more alarm manager. Work managers need the new thing. Anytime you have this Target SDK version related code, whether or not it's like the actual thing that needs to be changed, if it's something a bit tangential, that you're like, oh, this code is kind of old and kind of spaghetti, and maybe we could work it into our Target SDK version update. Now's your chance. So back to the concept of like, do you want to use Room or some new library? You should really be solving a problem when you decide to add a new library. But how do you know if you're solving a problem? Because your legacy code might not be tech debt, regardless of how old it is or when it was written. If you can make changes with confidence, you can run tests to make sure everything works. And if there's no bugs, well, regardless of how old or ugly the library is, it might not be tech debt. So when is it tech debt? If you're scared to change things because you don't have any confidence in whether or not you're going to break something, or if you do change something in one part of the code base and then something seemingly random breaks, then you have tech debt, for sure. So let's dig into this concept a little bit of random changes, breaking random things. So ideally, we want to prioritize tech debt that has the most impact and can be fixed with the least amount of effort, right? Something easy that helps a lot of people. So let's define impact first. I'm sure everyone can think of like one really annoying thing in their code base that just every time you see it, you're like, ugh, like I just have to move this out of the way, or like I'm tripping over this one thing. So that'll make you happier if it's fixed, right? Ease of maintenance. So if a new teammate comes in and has to maintain something or fix something or add a feature somewhere, is it going to be easy to maintain? Is there like a consistent pattern that can be found? And finally, and this one's probably the easiest to get manager approval with, does the user experience change if you tackle this tech debt? If you have a visible impact for your change, that can really help inform prioritization. So the other axis is going to be effort. If you just know that you have this big chunk of code and you just know it's going to be a bear to fix, like it's going to be super tough, that's going to be a lot of effort. You know that for sure. But there's also code that maybe you just need to change a few lines, but they can have these far-reaching consequences. So that actually does increase the amount of effort because you don't know what the changes are going to bring. Finally, is there some basic assumption in your code that was incorrect? Like doze mode isn't a thing. That's a basic assumption that is now wrong, and you have to go back and fix all those things, where you assume that the app can just do whatever it wants all the time. So these small risky changes that you don't know what they'll affect, this could actually spread throughout a code base, kind of insidiously like a virus. So let's look at this. So you have this classical currency util. Maybe you deal with buyers and sellers on some online marketplace. And in 2013, you're like, hey, we need to handle currency symbols we need to handle formatting prices for different locales and comparing across different locales. So maybe you just have like these 6 methods in this util class. It's pretty simple. But over time, people see that, oh, anything to do with currency, I can just throw it in this util class. So more and more methods get added. In 2014, just 1 year after this util class was made, there's a big to-do right at the top. And you're like, oh boy, what's happening here? And it says, hey, maybe this class should be solidified or consolidated. Maybe some other logic needs to be split off. And there we have like the tiny warning that this class is becoming tech debt. So ideally, you'd go in and say, hey, we have this to do. Let's make a ticket. Let's prioritize it. Let's fix this really quick. Let's nip it in the bud. Let's just stop it before it gets worse. But if you don't have a system in place for handling your tech debt, over time, more methods are just going to keep getting added. So in 2015, we now have all of this parsing logic that also is in currency util because it handles currency kind of, so let's just throw it in the same class. And so we have this like string parsing, it returns an object that knows it's USD with a numerical value, and these are all like static methods. So currency util is now referenced all over the place, anywhere you deal with money, again in this online marketplace app. So it's referenced everywhere, and the code is going to be more difficult to test because you have this static instance. So you might just throw your hands up and be like, no, it's too much, it's hopeless. We can never touch this thing, it's used everywhere. And these different methods may have different, like subtle differences in their return values, whether you use one or another. There could be even subtle bugs that would be introduced by trying to consolidate it because these other pieces of the code rely on the original, like maybe semi-buggy implementation. So it just kind of gets left there as a debt too big to handle. But you know that it's just going to keep getting worse. Like we've seen what happens in the past. We know what's going to happen in the future. It's just going to keep spreading. So we have to show and quantify that this really needs to be handled ASAP. So like a virus, there's a word for this, contagion. And I love this concept. So this comes from this really great blog post from Riot Games. They make League of Legends. And they have this blog post about their taxonomy of tech debt, where they have effort, impact, and contagion, which is trying to put a value on the risk of something spreading through a code base. So we go back to our nice little 2 axes from before. We have our impact and effort. And again, we want to fix the stuff that's high impact, low effort. But where do we have this 3rd axis now, this contagion? So contagious tech debt spreads just by existing. It can be spread via duplication. Maybe it's a pattern that gets used over and over by devs. Maybe new devs don't know that they're not supposed to use it. And it becomes harder to fix as time goes on. So how do we rank stuff that has maybe a high impact and low contagion, or a low impact but a high contagion? Even if there's a low impact on developer happiness and 0 impact on users, but if the tech debt has extremely high contagion rating, you probably should still fix it, just because it's going to get really out of control, and at that point, the developer happiness impact might go up. But at this point, the effort is huge because it has spread so far throughout your code base. When you're ranking it, against all these other pieces of tech debt that you have, you can try to keep it visual. So if your team would prefer just having that 2-axis chart, you can just make like a weighting function after you rank everything by contagion and impact. You can just kind of combine them and then just put that up on the chart. Or you can just have like a list that's generated, just plug in your effort, impact, and contagion values, and then you have your machine ranked list. But what do you do now that you have just this list of items with their rankings? So once you have all of that, we get into a process for planning and organizing. So this isn't going to teach you how to fix using Sprout method and everything. Go see the other talk for that. It's really good. This is just for talking to your manager. So which of these looks convincing? Well, hopefully we all agree that if you write up a ticket and it just says remove loaders, your manager's not going to know what to do with this. They're not going to know that this is important. They're not going to know that this is not good to have in the code base. But if you just have a template that says, hey, we want to remove loaders, we want to replace them in this particular fragment, here's the value in fixing it, here's how we fix it, and any further notes. They're going to want to look at this one. They're going to listen to you. So let's try to use a template to get this figured out. This is going to make it really easy to fill it out, because the hardest part about tech debt, like getting into the system, is you might have a Word doc, you might have a spreadsheet where you ranked like the risk and impact and effort, but if you actually just want to catalog it in a way that it can be done and picked up easier by other developers, you might need to use your Jira or your whatever that you use to make tickets. So just have this template, reduce the friction for cataloging it, just get it into the system. You really also want to show why it should be fixed. This is super important because if you're talking to other Android developers, you say, oh man, we're using async tasks and loaders, and they're like, oh, that sucks. What are you going to do about it? And then you talk to your manager, they're like, what? Like, is that bad? I don't know. So you have to really say why it should be fixed. Show why it's currently a problem. And if you notice that when you're saying why it should be fixed is that, oh, it's not just the latest and greatest, maybe that's less of a matter to worry about then. But if it's like actually a super problem for you, clearly say the value in fixing it. This is also super important, how it will be fixed. If someone new to the team comes on and wants to start working on a couple of tickets, they should be able to understand the context, even if they weren't a part of the initial writing of that ticket. You should mention where it's going to be fixed, the method you're going to use, and also important, the scope of it. This is also super important. Don't make one person do all this work. It can be super tempting. Like, I know you guys are going to go and you're like, oh yeah, I'm so fired up about tech debt. I'm going to do this all myself. Don't do that to yourself. And don't tell someone else in your team to do it either. Do it all together, collaboratively. It's a big Etsy value. So make it a workshop, because everyone on your team is affected by tech debt in some way. So just get together. You have a template. It's super simple. Just write up some tickets together. This is also important because you can discuss it collaboratively. You can look at the ranked list or chart and discuss whether you think the priorities are actually accurate. If something is very high impact and low effort, everyone agrees, that's great. If something is high impact but high effort, but people really want it fixed, maybe that can be bumped up. It's also just easier together. Say you have some people in the code who are really used to working with this older code or like this one particular legacy library. They have a lot more context about that stuff, but you can also pair them up with newer folks or folks who work in different parts of the code to write these tickets together. Not only will this make a better ticket, but also it'll increase understanding on the team of what is a problem in different parts of the code base together. So now you've got your list, it's ranked, it's up on your board, your Kanban, your Jira, whatever. You are so organized now, this is great. And even though you haven't done anything to the code, you're still in such a good spot now. But what's next? How do you actually get from that to being able to work on this code and fix this tech debt? So we come to how to convince your manager. Really, you are in a good spot, don't worry about it. But maybe your manager takes different kinds of, different ways of being persuaded. So let's look at a couple of different ways you can try to convince them. Maybe your manager likes speed. Well, features can be delivered faster without the weight of bad patterns. But eliminating tech debt isn't just about going faster. Maybe your manager cares a lot about stability. Maybe you've been fixing some bugs and it's kind of starting to feel like whack-a-mole with each release. Dedicate some time to stop up those gaps and reassure your manager. Say, directly link that these bugs are related to your tech debt and not just, rushing out for new features. Maybe your manager has a bunch of new people coming onto the team. If you're onboarding new folks, it's a lot easier to get comfortable in the code base if things are smoothed out, if they don't have to juggle 6 different patterns in their head to try to work on a couple of different screens. Some managers, they know the tech debt is a problem. Maybe they're getting some pressure from above to only focus on feature work. Maybe you're getting pressure from above to only focus on feature work. If you have a chance to estimate that feature work, and you have some relevant tech debt that you know is going to be a problem during that feature, just silently fold it into your estimate. Just bump it up by a few days, a week, 2 weeks even, depending on the effort of the tech debt. Just fold it in naturally. then maybe the manager doesn't even need to know that you're working on tech debt because they just want the feature to be delivered and delivered well. I know it's a little subversive, but you can do it. So finally, you can just do it. So if you have some spare time in an iteration, sprint, whatever you use, you have that ranked list that shows all of your effort values, all of your impact values. So if you have some spare time, you have like a day, say, oh, cool, I have this list. I know exactly what I can work on. And because the list was a collaborative effort, you can be sure that it's valuable work. Whatever you pick from that list, everyone on the team is going to know that this will help everyone. And you can mix and match from all the above, because everyone's team is unique. You know, maybe some managers like speed and onboarding, and some managers like stability and the other one, fold it in. Just do it. You're good. So finally, I have this section on putting it into practice, which again is not going to go into any code examples, but it does hope to offer like a bit of an FAQ. How do you know if a refactor is a success? And this was covered a bit in the other talk, which again, I really hope you go check out. A refactor does not mean you optimize or fix bugs or add features. There should be no behavioral change in a refactor. That's the definition of a refactor. So when you're fixing tech debt, it's really important you don't break things. Even if it's so tantalizing to just like, oh, I just want to fix this one thing. Don't change the logic, because then you're mixing things up. So a good refactor will clean up the code, but not optimize it. Just make it cleaner for developers to do. No behavioral changes. So you can actually codify this a bit in your tickets by saying like, hey, how do we fix it? Specifically say what you're doing, replace the callbacks only, no loading logic in this case. We're even still using cursor here, even though I'm sure like when you're working on this ticket, you're like, oh, it would be so good to just not use cursor, just use something else. Don't muddy the waters. You can do it in a separate ticket, and a refactor should just be like a tiny slice of fix this, don't change the behavior. So how do we test that it's the same behavior before and after? I don't know, there's some key word here we're missing. But it's hard to write tests on Android. Maybe your code is super legacy, it relies on singletons, databases. Well, again, working effectively with legacy code, this book by Martin Feathers, has your answer. You do a tiny refactor to write tests, and then you make sure that the main refactor doesn't change everything. So what if you're working on a refactor and you're working like, oh, this kind of feels too big, like I took on more than I could chew. Well, if you have 500 changed lines, but you have a lot of test-related stuff from your refactor, feel really good about this. It is hard work to get legacy code under test. And the changes can get a little gross, but because it's tested, that makes a huge difference. The code base is going to be so much better off when you have that confidence to know that, yes, I did change something, but I have a test. It works the same before and after. The refactor was a success. Maybe you were in there, you're doing your factoring, maybe you optimized a little bit, maybe you just converted the whole thing to Kotlin. Sorry, that's not actually good for refactoring. Be careful. It's so tempting to take a Java class and auto-convert to Kotlin as the first step, because obviously like Java is legacy code and Kotlin is the new hotness. I know, but it can really snowball. Like even just the nullability changes, you might just clean up a couple things here and there, make it a little bit more Kotlin idiomatic, but that could actually change the behavior. So until you have tests, don't just auto-convert things. This is why you write tests, so we can put more Kotlin in your code. You should do it. Maybe you had a feature that you needed to add, but it was absolutely impossible to add without refactoring. And this can definitely happen, sure, but like really try to keep it separate and have your team really review everything. If the feature is time restricted, like maybe a target SDK version update, it can be very difficult to keep it separate in different branches, different commits, etc. But really try to write a tiny test first, or do a tiny refactor to write tests first, then refactor, then add your feature, and write tests for both the feature and the refactor. It's a lot of work, but it's worth it for quality code. So if you've already sort of done this feature and refactor work together, and it's just all the same kind of big jumble of changes, this is going to sound a bit radical, but we're going to cast don't repeat yourself out the window, call that a rough draft and make all your changes again. This time, refactor first and do the feature second. See if you can split it up. And you may actually come with cleaner code than the first time around because you've already had that time to work through, okay, I had to do this to refactor, I had to do this to do the feature, I had to do this to refactor again. Once it's all split up, it could be very nice and clean. So give it a try. Say you're working on tech debt and your estimate was too low. So you can still pass that knowledge down. You know, you're working on it, you're like, oh, this is much harder than we thought. You learn stuff from that, so pass it on. Put it in the ticket. You can update the effort value, add notes on how to fix it, you know, whether you ran into roadblocks or, you know, one of these is just totally out the window and not working for how to fix it. And then you can also specifically call in or call out what's in and out of scope. So if you think the estimate is too low, then you can specifically say like, while I was working on this, I wanted to refactor XYZ, but don't do that because we're going to try to keep the estimate low. This is the worst case scenario. Oh my gosh, I introduced a bug. I was trying to just work on tech debt, but something changed. Okay, it's not too late. Write a test and then fix the bug. But even if it's a flaky integration test, this is still better than nothing. You really have to have tests in place for it to not be legacy code and for you to have confidence in your refactoring. So if you did introduce a bug, write a test that, you know, along with their fix for the bug, and you can replace it with a unit test after you refactor it again to get rid of that flaky integration test if you need to. So really, it all comes down to confidence. You want to have confidence in your own changes by making tiny refactors, writing tests, or making tiny refactors in order to write tests, writing the tests, and then making your refactor. You want to have confidence in your teammates. They should also be doing the same thing. But also, when you guys work together to prioritize these tickets, we should all have a sort of path that we're going to fix the code base. So you also want to have confidence in your whole process. You want to know that your manager is taking you seriously. You want to know that you're confidently explaining why this tech needs to be fixed. And yeah, it's all about confidence. Tests equal confidence. Just remember that. So really what we're trying to do with tackling tech debt is to lift a burden from the team. You know, your team has to worry about 6 different patterns, 8 different patterns, 12 different libraries, 4 different ways to do networking. It gets a lot. So even if you can just eliminate 1 or 2 of those, it's going to be really great for everyone on the team, not just yourself. We really want to try to flip the contagion around and make the understanding contagious. Ideally, once we get these good patterns in the code, they will also spread like a virus, but a good virus. So ideally, yeah, we can use contagion to our advantage by flipping it around and making it the understanding that spreads through the code. So when you're faced with spaghetti, straighten it out and leave it better than you found it. So thank you. Definitely check out Working Effectively with Legacy Code. Check out Chuck Grab and Mahit Sarveya's talk, which was earlier today. So if y'all missed it, it'll be up on YouTube. And yeah, thank you so much. I can take questions. Hi. Okay, so the question was, did we already have a concept on the team of what a good architecture is? And if not, how did we move toward that as part of this? Sure. So keep me honest, you. We had a little workshop first, before we were even talking about tech debt, we had a workshop to discuss architecture. We came up with a bunch of different patterns. It was less about, I think it was less about seeing what we already had in the code, because there were a lot of different things, because we had a lot of different people working on it, and more about just ideally what our visions were for the different apps and the different architecture styles that fit the apps better. And then your second question, I think, was, so if you can have tested code that's still bad code? Yeah, so definitely you can. Writing a test is the first step. So even if you have so you have some screen that is using async task and loader and all the stuff that you want to replace, just like write up an espresso test, even if it's flaky, to just make sure that you don't break anything. Because so much of Android, I mean, Android specifically, the code that we have from, the older days, 2009 to 2013, 2014, before we really had this community-wide renaissance of, hey, Android architecture is a thing. We can do things with different libraries. A lot of the code is going to be really difficult to unit test, if not impossible, which is why we have things like Rub Electric, all that stuff. So yeah, definitely writing the test is just the first step. And then after that, read this book, do it. It's worth its weight in gold, seriously. And just the ways that you can, once your stuff is under test, just refactor it like tiny bits at a time. Does that answer your question? All right, cool. Yes?
So, say you're starting a new project, what suggestions do you have to keep on top or keep ahead of the tech debt?
Yes, that's good. I would suggest checking out Writing Code That Lasts Forever, for sure, because that was a whole 45 minutes on this. But I would say basically test stuff, because if it's tested, then it's not legacy code. And the people who follow after you aren't going to have to, force push to master everything that you've done. But yeah, it's really about like spreading that confidence, and tests equal confidence. So when you're writing new code, write tests for it. Maybe write the test beforehand. That's a thing. So yeah. Yes? How to convince your teammates? So I guess I'm kind of lucky at Etsy. All my teammates are really on board with getting rid of tech debt. So I would guess, you could probably just use the same strategies. Like if your teammates are, concerned about speed or stability or anything that a manager would be concerned about. Is your problem that they want to focus more on feature work and like they can fix it later, or? Yeah. So if you have teammates that don't agree on what the tech debt priority should be, yeah. So I would say still have that workshop that I alluded to, where even if only one person is doing the cataloging of what tech debt is available, still have the whole team looped in to be like, what is the priority of all these? And like have the whole team work together to fill out like this piece of tech debt is important because XYZ, and then maybe you can make your case in that collaborative environment. Does that make sense? Or okay, cool.